Hello everyone, my name is Chris Tung and we are the ACK DNY group. Our game we have here is called Atmosphere. It's a multiplayer 3D game. Let me introduce the teammates. Here we have RJ. He is in charge of sound, network, and systems. And next we have Kyle. He was in charge of modeling, physics. We love him too. Here's Yuri. He's in charge of the controller, the particle effects, and what else are we in charge of? HUD. Yeah, he's in charge of the heads-up display. Next, we have Daniel. He's also in charge of physics, but he's mainly he mainly worked with the camera, the way the characters move, and what did you work on? Oh, he's our math guy. He's our go-to guy for math. Yeah. Next we have Nick. He's in charge of. He worked on pretty much the whole graphics system. He got everything started. He also helped with game logic and other bug fixes here and there. And I'm also in charge of game logic. I also worked on the asset manager, and I also helped out with other utilities, shared memory, and all that. Okay. First, we're gonna need 2 people to play this game. Guess there's one right there. And anyone else? This guy up there. Sorry. 2 people max. So first off, I want to thank Jeff Falker, for the inspiration, the ideas, and mainly the food he brought us. Next, I want to thank Alex for fixing all our bugs, inspiration. Next, I have Lee Zhao. He helped design the music. He's not part of our team, so we want to thank him. And next, we have Tamir. He was our logistics guy. Again, not part of the team, but we want to thank him for all his help. All right. Let's get the game started then. So, what inspired us to design this game was a game called Super Stardust. It's a game that that revolves around a planet and pretty much has no boundaries. Next, we had Geometry Wars, which had a unique style of playing where you don't have to be in the direction, you don't have to shoot in the direction you're looking. Right now, we're using Xbox controllers to maneuver. It's a new thing. We only use 3 buttons. One of them is to maneuver left and right, or to control the spaceship. The next analog joystick is to shoot, and then we have a trigger where we could boost, make the ship go, I guess, turbo up. Let's see. So this is I guess a free-for-all game. The goal of the game is to get as many points as you can. In the corner over there, we have our scoreboard. If you're the player, you're the very first score listed, and the score is color-coded by player number. And to capture the base, you have to hover around it for about a couple seconds, and then it's yours. You earn a point for capturing a base, and if you hold onto a base for a certain number of time, you also earn points that way too. Again, when you're capturing a base, you'll see a little icon show up stating that you are capturing a base, and the next thing is we have items that we could pick up. What it is we get different kind of power upgrades. In the corner up there, we have shield, which will boost our shield level. We have attack increase, and we also have a speed boost that's independent of our turbo. In the bottom corner, we have our health level or shield level, and beneath that is our boost. We can only use that once until it recharges. See how it depletes? Let's see. So we have a total of 4 weapons. We have the Gatling gun that you just saw. The next is the flamethrower. The one after that, we have rockets, and beneath that is the plasma gun. And they all have different strengths and weaknesses. For example, the flamethrower, you got to be fairly close to hit the player, but the damage is a lot greater versus the plasma, which could shoot farther. Each weapon has a power-up, like a level, and the higher the level, the stronger the weapon gets. And that's you can level up by picking up weapons. And then down in the corner there, the right-hand corner, we have our radar, which is color-coded based on the player, and it displays the player location and also the base location. And so I'm gonna hand the mic over to Nick, who's gonna talk about the graphics.
Just want to explain a little bit about the graphics and the kind of technology that we're using. What you see, we're using all shaders here to draw everything on the screen. The majority of the rendering engine is done in shaders. For the demo machine here, we're using shader 3.0, but for the other ones, we're using shader 2.0. And mainly, we're using the number of instruction increase for the shader 3.0. Because for shader 2.0, there is a limit of 64 arithmetic instructions, so it's kind of limiting. We have 6 light sources in the game. There are 2 global directional light sources, which are sun light sources that are at the poles of the world right now, and the remaining 4 are point dynamic light sources that are moving, following the player, as you see. So the terrain here is being lit by the player that is hovering above it, and the color of the light also transferred that to the terrain, as you can see. The thing is, originally we wanted to have a lot more light sources. For every moving object on the screen, we were thinking about doing a light source, but that wasn't feasible realistically, just because of the instruction count. Also, the world rendering is just want to describe some of the stuff we do for the world. We're using normal maps for a lot of the details in the world, so that we could get away with not modeling a high polygon count for the actual mesh text, actual mesh object. So a lot of the detail comes through the normal maps that you see. Also, the coloring is done. The coloring for the terrain is done on a height function. So you can see that around the edges, it's kind of beach-like. The color is yellow for beaches, and then it transferred to grasslands as it gets higher, and eventually you'll hit the mountains and you'll see the snow tops at the very top right there. That's all done in the shaders with a function of height, basically. And the water that you see in the back, it's done also using a similar technique. We're using normal maps, but in this case, they're animating normal maps, and we also have a reflection on them from the cube map in the back. So that kind of plays as a specular lighting on the oceans. There's also clouds that we've added, and the clouds have a little bit of a volume. That's hacked a little bit just because of the way the shaders pass through interpolated values into the pixel shader. So you have a nice volume to the clouds. But also another neat feature is that depending on which side of the world you're on, the clouds are actually darker depending on which side you're. So if you see in the darkness, as you go, the clouds are darker on this side than there are on the lot brighter side of things. There's also the atmosphere that you see, the glow behind it. That's basically done in a sprite, a big, huge sprite. Did the texturing in Photoshop, and the hard part was just getting a nice fade off, because you can't have any edges on the fade off as you go into space. There's also, those are all done in the particle system, and I'm going to be handing it off to Yuri here, who's our particle system guy.
Hello. Yeah, so I was the one in charge of doing the particle systems. The hardest part was to actually get it done in a relatively short period of time, and especially get it to the rest of the team so they can integrate it into our project. I spent a lot of time thinking about how to take the basic simple particle effects code and make it easy to use and natural for the logics part of the game. I guess the hardest part was actually figuring out the different particle effects that we wanted, different views that we wanted to get with the camera work that we're doing right now. And I think it turned out pretty well, actually. Yeah, so now I'm going to hand off to RJ, I guess, who's going to talk about a bit more network side of things and systems.
Yeah, I just did networking and systems. I think for sound, and sound, yeah. So for sound, all I used was Fmod, and that was like pretty much plug and play. For networking and systems, I think the hardest part was to get a design down so everyone can be separated and not really know about networks. So what we did was we created, we kind of stole from threading, and we treated the clients and the servers as just different threads. So they shared like a shared memory block, and it would just get updated to the clients, and the clients would just read from it. So yeah, that's about it. I'll pass this on to Kyle.
All right. Well, one of the challenges of this game was making a 3D game sort of play like a 2D game. We wanted to implement a simple game design in that you really didn't have to, learn very much to get going. It's, it uses an Xbox controller. You pretty much just fly around and shoot, and it's pretty simple. But implementing that in 2D and yet sort of still maintaining some of the three-dimensional aspects to it, we had to do some tricky things, and one of those was some of the physics functions involved. The ships are all based on physics. There's a gravity, and the controller's linked directly to the thrust vector on that ship. But then there's a lot of hidden vectors that you don't really see. There's a hover force that keeps the ship sort of elevated above the ground, and so that hover function lets you fly over the mountains, but you don't really have to worry about crashing into them. All of the bullets are also implemented with that same function, so you can the bullets will actually kind of fly around the contours of the planet, so you don't really have to worry too much about aiming necessarily. The ships all have a drag force, and I guess in conjunction it all kind of looks and feels sort of smooth, and that was the implementation we were going for. All right, we're going to conclude with Nick here.
So I'm going to introduce our math guy here, and he's going to talk a little about the problems that we encounter during the game design and things like that and implementation.
Hi, so as Kyle was talking about, we were trying to make the game kind of a two-dimensional logic, and when we're actually mapping it onto a three-dimensional sphere. And initially we were trying to do it as two absolute angles rotated around the y and the x axes, and you run into this problem called a gimbal lock, where if you rotate too far around one axis, when you try to rotate around the second axis, it kind of overlaps. So the y-axis and the z-axis can overlap, and so you get this weird figure eight motion, and it's phenomenal the kind of problems it can cause. And I think each one of us had our own share of problems due to that. I mean, when Yuri was first trying to implement the camera, he couldn't. There were problems with it gimbal locking, and then AI as well. When we were trying to create a positioning system for the artificial intelligence, and we were running into problems, and we ran out of time to implement it. And so, as you can see, as Kyle mentioned as well, it's all based on physics, and so the controller actually feeds the server kind of a force vector that accelerates the object, and so we keep track of velocity. And so if you look at how the camera tilts a little backwards, so what's happening is based on the velocity of the ship you're focusing on, the camera will kind of tilt it backwards. It will multiply the velocity by a negative constant, and then refocus the camera's look at onto the ship. So then it looks like the camera is kind of tilting behind the ship, so you get a better view of what's in front of you. And so for anybody who's going to implement a game like this, like a flight simulator or whatnot, as a word of advice, to overcome that phenomenon of gimbal log, what you have to do is, if you're rotating around two axes, you want to, instead of keeping track of the absolute angles, what you want to do is you want to just make incremental changes to the actual matrices. And if you have a three-dimensional, if you want to do it around three different axes, you need a fourth degree of freedom to be able to keep all the axes independent. So what you do is you use something called quaternions, which is inside the DirectX API, and it's a lot harder to visualize, but you won't run into the axes locking on one another. And so yeah, I think that's it as of now. And so we'd like to take this time to take any questions. Go ahead. Uh-huh. Yeah, there was a game for the PlayStation 3 called Stardust HD, and we kind of, that was our inspiration. It's also based on a spherical world, and yeah, in that game it's more like what do you call that? Like space. The old game. Space Invaders. There you go, where you just run around and dodge the enemies and their shots. And any other questions?
You mentioned artificial intelligence. Are there computer-controlled players here?
Oh no, we didn't have time to run all the create artificial intelligence just because the positioning system wasn't done by the time we had to present the project. So. Go ahead. Oh, which? Yeah, sure. You first.
So, did you guys actually have to create the physics from scratch, or is
We just used Oh, do you wanna? Yeah.
I wish there was an easy physics engine that you could just plug and play, but it wasn't that easy. We actually just built it from scratch, and initially we had some, I guess, very demanding goals, and not all of them got met. And you know, what you see here is sort of the watered-down version of what we intended in the beginning of the project. But basically, it's some of the things are actually tricks, and some of it's physics. You know, for example, when the ship rotates based on the Xbox controller, it doesn't actually apply a force. It rather than applies a difference from the ship's orientation and the controller, and then multiplies that to the angle, and then it looks like it is nonlinear, but it's not the true apply a force, give it a torque, and then rotate. But the moving around the planet, those physics are actually more or less correct minus the drag. The drag is a function that's actually a linear function, and it's not the exact function you'd use for a drag force, but it works quite well. You know, it's kind of, you kind of have to, I guess it's a compromise of, you know, how accurate you want to make it versus what's playable and how much time you have. Does that answer your question? Take some more here. We'll go with you and then you.
So I'm curious about the planet geography. Did that come early on? Is it just kind of sat around, let's put a landmass here? And could you actually change that?
You know, we modeled the Planet 3 Studio Max, and it was kind of just drag the mountains out and put the, you know, I guess Nick was sort of in charge of that design, and he wanted some oceans and then some mountains, and then. Yeah, it did, and then we kind of wanted to make another one, and we actually didn't make the final map. This was sort of our beta, I guess, but You know, I mean, it's yeah, we got the water and the mountains, and yeah, as Nick said, he did the whole texture height map thing. So.
Just a curiosity about the bear I've seen it in the last two projects. Where I get the 3D models.
The 3D models, where did we get them?
Bear one? Bear one is the class resource.
Oh, the bear. Yeah, that was actually given to us. Yeah, from I don't know who. I actually don't know the artist that made the bear.
When the bear was installed in campus, as part of the project, they did a very detailed study, a very detailed structural study to make sure that they could build a foundation that would hold the bear. As part of that, they did a laser range finding analysis of all of the stones comprising the bear, and then we were able to get all of that data. And a couple of years ago, the TA for the course reconstructed it into the model. And ever since, almost all of the games have incorporated the bear in one form or another. It's a great theme.
I'm not sure if anyone in this group has even played that game, but I'm sorry. Okay, Yuri has.
Yeah, initially we did want more planets. We were going to actually do a whole solar system and have the ships kind of escape off the planets and go to other ones, and we threw that out. That was just too much. It was hard enough getting this little one going. But I had played Mario, but I think most of the inspiration came from that Stardust game from PlayStation, which was pretty fun. Are there any other questions? Okay. The timer goes up to it's I guess 8 segments, and then the base changes color to indicate that it's your base that you captured it.
If the owner of the ship, if the owner of the base is present in the vicinity, then you cannot capture the base. So the timer shouldn't start until the owner leaves the area or the vicinity. Two opposing planes, the first one gets hit. Yeah, I mean, it's very, very unlikely that two will exactly hit at the same time. But I mean, if that happens, I don't know. We'll in a binary system, you know, it's kind of hard to choose that middle area of 0 and 1, I guess. Any other questions? Nice.